Okay, this is your video on the thermochemical equation. All chemical equations have some sort of energy represented in it, so because all chemical reactions have some sort of energy transfer. Now, an energy that is often used, because it's easily measured, is thermal energy, or what we call heat. So the heat transfer in a reaction is called the change in enthalpy of that reaction. So enthalpy change is indicated with a delta H, as I have right here. Okay, or it can be sometimes indicated with a Q. Okay, so some of the practice trying to do might have Q, some might have delta H, but essentially they are meaning the same thing for this practice. So if energy goes into the reaction, it is considered to be an endothermic reaction, and if the energy is being released, it is considered to be an exothermic reaction. So usually the way I like to think of it is endothermic is going in, exothermic is exiting or leaving. Okay, endothermic reactions have energy being absorbed. Okay, all along the same lines, exothermic is being released. So changes in enthalpy that are endothermic are considered to be positive. So my delta H is actually a positive number, or my Q is a positive number. And if it's an exothermic reaction, that means it's negative. So delta H would be negative value, or Q would be a negative value. Now, we know if they're positive or negative based if they're endothermic or exothermic, but the units that we are using here are kilojoules. Okay, joules can be used, obviously it's the base unit, but it's not practical considering that a joule is a fairly small amount of energy. So, we have an example. Okay, nitrogen monoxide reacts with oxygen gas to form nitrogen dioxide. This is a synthesis reaction, has a heat change of positive 802 kilojoules. What is the heat change in kilojoules? Accompanying the production of 3.98 grams of nitrogen dioxide. Okay, so obviously we have a reaction here, so we need to write the reaction first. Okay, so nitrogen monoxide reacting with oxygen gas to form nitrogen dioxide. Okay, balance the equation. We should have 2 here and 2 here. Now, with that, having balanced, we also need to indicate that there is a heat change, and in this case, the heat change is a positive 802 kilojoules. So what we'll usually have is either Q or delta H will be written off to the side, saying Q is equal to, in this case, positive 502 kilojoules. And all that means is in this reaction, it's endothermic heat is going into this reaction. Okay? So, the stoichiometry for it. It's pretty straightforward. Now, what's important to realize is that 502 that I circled in red, I wrote down here with the equation, which means it's part of the equation. It is not considered to be a given value. It is a literature value. Okay? So my given value is right here, this 3.98 grams of nitrogen dioxide. So, I'll start with that. 3.98 grams of nitrogen dioxide over 1. And I know that for every 46.01 grams of nitrogen dioxide, I have 1 mole of nitrogen dioxide. Okay, pretty basic, just like any other stoichiometry problem, I got to get to moles. Okay, and now here my next step is, now that I'm at moles, this value right here is representing the energy value or the energy change in this equation as it's written, which means if I have 2 moles of nitrogen monoxide being used, it's going to have 502 kilojoules. If there's 1 mole, 502 kilojoules if there's of oxygen. If there's 2 moles of nitrogen dioxide, that's also 502 kilojoules. So in this case, I would have, for every 2 moles, as indicated on the equation, of nitrogen dioxide, I have a positive 502 kilojoules energy heat transfer. Okay. I cross my units out. Grams. Oops. Change color there. Grams. Grams. Moles. Moles. I'm left with kilojoules. Okay. And when I do my math, I'll end up with 21.7 kilojoules. And it's important to realize that that symbol needs to carry over. Okay. It's ugly positive 21.7 kilojoules. So what this means is, if I have 3.98 grams of nitrogen dioxide being produced, I'm also going to have absorbed 21.7 kilojoules of heat. Okay? That's all it is. It's just another part of the equation. Okay? So let's try another one. Ammonia, nitrogen trihydride, is formed when hydrogen gas and nitrogen gases react. The reaction is exothermic with a heat change of negative 1610 kilojoules. If the reaction has a heat change of negative 1,240 kilojoules, what quantity of hydrogen reacted in grams? So now, on the last one, I went from grams to energy. Now I'm going to go from energy to grams. Okay, and I'm going to use the equation, which we have to write out. Okay, nitrogen gas and hydrogen gas react to form ammonia, or nitrogen trihydride. I balance my equation, and I also have to indicate that my Q, or delta H, is equal to negative 1610 kilojoules. Again, that is a literature value. It is not a given value. And I know that gets kind of confusing, especially on a question like this, because I have two values that look, they're both energy. Okay? But this is your literature value. This is your given value. So let's work with it. Negative 1,240 kilojoules over 1. And I need to get to moles. Well, according to the equation, for every negative 1,610 kilojoules, I have 3 moles of hydrogen gas. Right? Because this is my value, and there's my number of moles. For every 1 mole of hydrogen gas, I have 2.02 grams of hydrogen gas. So I'm just converting moles back to grams. When I do my canceling out, my kilojoules cancel out, my moles of hydrogen cancel out, and I have grams of hydrogen. My final answer is 4.67 grams of hydrogen. Okay? Now, it's important to realize that this is obviously can be expanded to be used with limiting reactants as well. Okay? And we'll do some more of those too. But for right now, what I want you to do is, there's a link that's attached to the classroom announcement where you found this video. Okay? Go to it and do some problems. They're going to look very similar to what I just did here. The only difference is they're actually giving you the balanced chemical equation already, and they're giving you all the formulas. They just want to make sure that you can do your dimensional analysis. Okay? So go ahead and work some problems out for practice tonight, or today in class, and tonight. So you'll have a practice form tomorrow, and then an assignment tomorrow night. Now, this assignment is essentially replacing a lab. So it's going to be a big ticket, a big point value assignment. Okay, we're talking probably around 50 points. So do your practice today, do your practice tonight, do your practice tomorrow, and then tomorrow night you'll have your assignment. Okay.